Right. We've transformed all the text and loan data strings to look like numbers, but these values are still text. On that note, let's display the string dataset. We see that it's indeed full of numbers saved as text. It's about time we changed that.
In a new cell, use the assign type method to cast these strings into integers.
From all available numeric data types, we choose integers because we've assigned the values ourselves. And we know none of them are complex or even decimals. Therefore, int is sufficient. We can specify whether it's 8, 16, or 32-bit integers. If we don't, the function will automatically assign the smallest data type, which successfully stores all these numbers. However, this isn't an issue we need to worry about when our dataset contains only 10,000 observations. But good practice dictates we should be cautious with the memory space our script requires. All right, everything looks good. So we can store these values over the entire dataset. To make sure we successfully converted everything, let's display loan data strings one more time. The so-called strings dataset no longer contains any non-numeric data, so we're ready to move past manipulating text in NumPy. Before we do so, let's quickly create a checkpoint for all the changes we've made to the former string dataset. Lucky for us, we only need to call the checkpoint function we defined in the previous section and provide the right arguments. Hence, we write checkpoint, and in the parentheses, we'll set a name for the NPZ file we're creating within quotation marks. The name should be descriptive, like checkpoint strings, for example. This function requires two more arguments, one for the headers of the dataset and another one for the dataset. In this case, these will be header strings and loan data strings, respectively. If we run the cell now, we'll see an interesting message on the screen about an NPZ file. This occurs because the checkpoint function we defined earlier loads the NPZ we're creating and then returns its values. Therefore, it's a good idea to store these values in a variable, which we'll call checkpoint strings. So let's create said variable and assign to it the output of the checkpoint function. When we run the cell now, there is no output, just as expected. Then, in a new cell, we can call checkpoint strings and within square brackets and quotation marks, write header. This should display the header we stored in the NPZ, and the output on screen verifies this. If we copy this line in the next cell and replace header with data, we should get the former string dataset, which now contains numerical values. Perfect! If we want to be absolutely certain that the checkpoint data matches our pre-processed dataset, we can use the array equal function and compare the two. Unsurprisingly, the output is true, so the two are identical and we can move ahead. Excellent work, everyone. All the hard work we put in has paid off. In the next part of the practical example, we'll go over manipulating numbers. Thanks for watching.